Why is it useful in identifying specific events or stages in the thermal decomposition process? What advantages does the DTG method offer when interpreting the data from TGA, especially in terms of detecting sharp changes or transitions in mass loss that may not be as easily identified in a traditional TGA curve? What role do both static and dynamic methods play in the broader context of material characterization, and how does each method contribute to a more complete understanding of a material's thermal properties? Can Davis Zurins manufacture solid-state sodium-ion batteries made from seawater in Latvia? What role does DEG, derivative thermogravimetry, play in research for sodium-ion batteries, and how is it particularly useful for studying the thermal stability of electrode materials and electrolytes? Why is thermal stability such an important factor when evaluating electrode materials and electrolytes in sodium-ion batteries? How does DTG help in understanding the behavior of these materials under various temperature conditions, and what kind of information does the DTG curve provide about the rate of mass change during heating? How can calcination in an inert gas be used to study the decomposition temperature and crystallization temperature of electrode materials? And why are these temperatures significant for understanding the performance of sodium-ion battery electrodes? What specific information can be obtained about the electrode material's thermal behavior when calcination is performed in an inert gas, and how does this method contribute to the understanding of the material's stability during battery operation? Why is it important to study both the decomposition and crystallization temperatures of electrode materials, and how does this influence the development of better materials for sodium-ion batteries? What happens when calcination is done in air instead of in an inert gas, and how does this change the type of information that can be studied? How does calcination in air allow for the investigation of the composite components and content of the electrode material? What specific insights can be gained about the composition of the electrode material when it undergoes calcination in air? Why is this process especially valuable when studying carbon composite electrode materials? And what role does carbon play in the overall performance of sodium-ion batteries? How does DTG data help to assess the presence and behavior of carbon in composite electrode materials? And what can it reveal about the interactions between carbon and other components during the calcination process? How does understanding the decomposition and crystallization behavior of carbon composites in electrode materials contribute to the design and optimization of sodium-ion batteries? What broader implications do the findings from DTG studies have for improving the thermal stability and efficiency of sodium-ion batteries?